Alright, so this time it won't be sideways. Alright, so I'm going to I came up with this wireless system. It's 4-bit, tileable up to 8-bit. It can send binary signals, and I've tried transmitting pictures across, and it kind of works, but I'm going to show you the basics of how it works real quick. Let me go fly over to the thing, the demonstration one. Now, it uses a addressing system and then just the transmitting data system, so it's pretty interesting. Took me a few weeks to develop it, but I finally got it working. As you can see, there's many prototypes everywhere. Oh, yes. Okay, so the basics of how this works is... Let me quickly fix this. It uses a strange burnout clock, and what the burnout clock does is you have a torch on a block facing north, and you make that torch into a burnout clock that looks just like this. Once it burns out, if another torch is here, you wait like a few seconds, and then you let that burn out. First of all, that's not right. They should still be going, but they're not, which is the thing that I use here. So, that lamp, all it is that whenever that flashes, it'll just turn on the lamp. But if I place this, as you can see, it detects it. That's the magic of this. That's how it works. It will also detect piston movement. Like that. That's what I use to transmit signals through this. This circuit right here, this is, all that does is just, if this starts flashing, you just break and place back that torch and it will fix itself. Alright, basically, how this will work is this transmitter uses subtract comparators. There's a latch, the 4-bit addressing code, latch, 4-bit data code. This addressing code uses 4 pistons that will send out a series of pulses. These are 1 tick apart, so it'll make the pulse longer or shorter. This thing right here will receive it, and if the right levers are flicked, these subtract comparators will activate. If the pulse is long enough, it'll go through this, turn off these, and if the pulse is right, these comparators will be deactivated, causing this whole AND gate to shut off, letting this subtract comparator let the pulse through into the next part, which decodes those pulses back into binary systems with T flip-flops. Now, let me demonstrate. So right now, this addressing code is first lever, third lever, no second lever, no fourth lever. So, I might be mistaken, but that should be it. Now, I have all the data codes off, so that should reset itself. So let's see. Yep. Reset itself. That's the right code. Now, do that. It should be the 2 middle ones. That will be code 6. Yep. Now, we are going to try to reset that, but I'm going to have a different addressing code, and it should not work because of the addressing code system. Should be foolproof. Also, I've tested it before, so I know it works. I'm just showing everyone here. Nope, but if we flick the right levers, ta-da! Alright, now I'm going to show you how to build it. I want a different color. Actually, I'll do black. Alright, so we're going to head over here, and we're going to get to building. First, we're going to start with the transmitter, then the addressing system, and then the binary output. So, transmitter. For 4-bit, this is just going to be latch for addressing, latch for data. You can increase it up to 7-bit. I've done a 7-bit one. It's latch, 7 address, latch, and then 7 8-bits, 7 data. All right, but we're just going to do the 4-bit. I will show you how to expand them though. 1, 2. So latch 1, 2, 3, 4. 1, 2, 3, 4. Then a latch, and then the 4 data. Latch, 1, 2, 3, 4. Redstone, like this. One, 2, 3, 4. And then just lamps right here. Very simple. Alright, now for the blocks. Blocks are also quite simple. And then they're going to go across and make like humps like that. And all these subtract comparators do is that when you flick a lever, this will be powered on from a NOT gate down there. But when these lamps are flicked on, when that button down there is pressed, it'll let all the ones that were flicked activate, including the latches, because the latches are power locked on. But basically, this is just the part of Minecraft that's based on hardwiring computing. So you hardwire the computer. It's not using command blocks. This is all possible in vanilla survival. Trust me. It's just a really weird glitch. They haven't fixed it for like 2.5 years, so don't know if Mojang knows about it or not, or they don't know how to fix it. But it is very cool, and if they do remove it, I will quit Minecraft because it is so good. It would like ruin the game. I mean, I don't know. I wouldn't. I'm just going to put buttons on all sides for convenience. Alright. The latches activate. No. My goodness. Okay, now, it doesn't need to be sticky pistons for this. It could be a normal piston. They can be facing forwards or up like that. I would just have them facing up. And you need to put them in front of all the comparators. There's no redstone torch. Oh, I put it there, that's why. I was confused. I was like, wait, what? Shouldn't have activated. Alright. Okay. There we go. Now, on all the lamps, place the lever on the front face. Nowhere else. Front face. Like this. Alright. Now, that is the receiver all done. This is the addressing part. You flick the corresponding levers to the part we're going to build next. That will be its address for that receiver. That's what we're going to build the receiver next. This is the data binary that you want to send through the system. Now we are going to go over here and get to work on the second part. So, to know which way is south, you want to make sure you have cords on or else it won't work, or you won't be able to tell. But you want to walk in the direction where your Z value is going upwards, that you're then facing south. You want to place a block, a torch facing south. Nowhere else will work. Has to be south. Block on the top of the torch, make a burnout clock. Wait for that to burn out. Wait a few seconds. Torch, block. And then you have voodoo magic. And when I place this down, flashes. That's the magic of how this will work. Okay. So blocks like this. Repeater. Redstone. Torch. Let that burn out. There we go. Alright, so that is technically the clock that will detect the, see? Lamp flashes when I place that down. It's, for people who've never known this or seen it before, it is like wizardry. It's just so bewildering to them. But, yeah, alright. So you want a simple repeater. 1, 2, 3, 4. Also, the block choices doesn't matter just as long as they're not transparent. They have to be a solid block. Transparent blocks are blocks like glass that you can't send a redstone signal through for, say, if you put a redstone repeater there. Like, you couldn't send a signal to the redstone. Like, if this was glass, it wouldn't work. But if it's like, so let's say stone, it would, because stone is a solid block. Glass is not. So you need a solid block. It doesn't matter what it is. Alright. Now, torch, redstone. Now, this is the actual addressing system here. So, I will explain to you in depth, as best as I can, how this works. It is very weird and confusing. But, basically, comparators that you have here correspond to the levers on the first part that should be flicked. So, the 4 addressing levers here, you would have to have those corresponding ones flicked for every subtract comparator you have here. If you don't want a lever flick, let's say you want the first 3 levers and not the 4th. It goes 1, 2, 3, 4. So then you'd remove this one, torch, then block. But for all the others, you just want a torch on top, like that. So that's what we're going to use. And you make sure you put that torch on the bottom so that turns off. And then you place blocks here. Block there. That is very important. It will not work if you do otherwise. Redstone across. Torch here. Block, block, block. Comparator in here. Redstone across here. Redstone here. Redstone here. Torch. Subtract comparator. Block, block. Subtract comparator. Redstone, 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 redstone. Repeater set to 2 ticks. That is very important. Comparator. No, comparator. Comparator. These are not going to be on subtract. And then repeater. And redstone along like this. There we go. That is the addressing system, all and done. Now, second part is going to be to add the binary decoder. How that's going to work. It's very similar. Make sure these are also solid blocks. Block, 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 like that. Block here. Don't need a block there. You can, but it's not required. Subtract comparator. Redstone, 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 redstone. Double compare. No, not comparator. Repeater set to 2 ticks. 1, 2. There we go. Comparator, comparator, repeater. Same pulse extender. Now, just run redstone along the top like this. It's very similar right now. Not place a torch there. That would be bad. Torch, torch, redstone, redstone. These all need to be here. If you don't have one, it will break. Unless you're doing a 3-bit system, but those don't really work very well because it's basically 4 and up to 8. 16-bits ones are huge and really complicated, and I still have not really figured them out that well. But I will eventually. I know it's possible. Redstone, like this. Torch here. These repeaters that I place, 2 ticks. All of these have to be set to 2 ticks. These ones, 1 tick. Redstone, 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 redstone. Black wool, or not black wool. It doesn't have to be black wool. It can be any color of wool, any color of block. Just not a transparent block like glass. Or like a slab. Make sure these are set to subtract. If they're not, you'll have a bad day. Okay. And then place blocks on top. Redstone, 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 redstone. Lamp, 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 lamp. There you go, you're done. Now, we want the first 3 levers flicked. So let's test it without the first 3 levers flicked. We're going to send a 6 through the signal. 1, nope. 2 plus 4 is 6. So it shouldn't send through. Nope. But we get the right addressing code, which it should be that. Yep. Corresponding. Very cool. Wireless transmission. Who knew? Yeah, so instead of this being 4, you can have it 8, latch 8. This, you make 8 long instead of 4 long. This has to be at the very end of it. It can't start at the front. It has to be at the very end. So, like, let's say we had one 8 long. That goes on for, like, 8 more. It would still be at the very end. And then on an 8-bit, well, 7-bit is one that you can run and be safe. For 7-bit, you just wouldn't have this comparator by default, and it would be this plus another 4. I'm sure you could figure it out. It's not that hard. And then, so basically, I explained how this would work. How this works is it does the same thing, but it's with a catch. It'll send pulses through, but there's no addressing system. In place of that, you have a decoder that'll decode the pulses from these. While that is extended, it'll allow pulses through until this turns back on. So this will turn on, shutting these torches off, letting pulses through. Now how it'll work is when a pulse comes through here, it'll activate this comparator loop, and it'll stay on until this will activate it off. Now, there's 2 of these, but each one can activate either or both variables. And how it does that is, first, this will shut off, meaning these are both locked. But if, let's say, this one activated, it would keep this one, it would turn this one off. So this is off, which means this torch is on. They're both powered, but if a pulse comes through this one, it's going to turn that one off. That's how this can variable these off and on and off. So that's how that works. All right, so I can going to also show you the 7-bit system over here. That was another one of the 4 bits. This is a 7-bit system. I have to fix it because it breaks all the time. That's how it works. Just really likes to break. So yeah, the only downside, if this is on a realm and like there's always at least one person online, it won't ever shut off. So it's really nice. There we go. So that's 7-bit system. Now, the right address should be all of them flicked. Oh, wait, that isn't, wait. Oh yeah, I didn't put an addressing system on that. That doesn't matter. So like this pattern here should reappear there. Oh yeah, and there's no wires to this, I swear. Look. Yep. If we were to change up this. Oh yeah, 7-bit codes are really strange. 110010. 110010. Works just like that. Very easy, very simple. It's pretty cool. Pretty cool.